Our next speaker is going to be giving a presentation from Microsoft's Data for Good, leveraging differential privacy. She is an advanced science researcher focusing on digital safety, security, and trust. Please welcome to the stage Mayana Pereira. Here you go. No.
Hello, everyone. Can you hear me well? Guess so. So I'm Mayana Pereira. I am a research scientist at Microsoft, more specifically at a team called the AI for Good Lab. At the AI for Good Lab, our mission is to really engage in socially relevant problems that we can solve, or at least help bring some clarity or some kind of solution using AI, data science, and privacy-preserving technologies. One of the successful pillars inside our team has been publishing data sets using Microsoft telemetry data and customer data in a responsible way. And what we have seen is that when we think about opening data, data that has been locked inside, our telemetry systems and no one has access to it and touch it, we can actually bring interesting insights and clarity to problems or scenarios that would be so hard to get data. So this is what I'm going to talk about today, and I hope you enjoy it. So what is the big motivation here? So the big motivation is that opening data opens so many different opportunities, and this is not something that comes from Microsoft. There's so many different organizations out there with the same thought process in mind. I'm bringing here some of the Microsoft quotes, but also external organizations such as GovLab, which also works with open data. It creates opportunities, it brings clarity, it empowers, citizens, and we at Microsoft, we are hard believers of open data being a game changer for not only the industry and researchers, but for everyone. And then when you think about, opening data sets and thinking about opening telemetry data, the natural question is, well, Jack just mentioned, let's ask Google or, I don't know, ChatGPT or your favorite LLM. And the thing is, if you don't have data to feed your LLM systems, you don't get answers. So one of the projects I'm going to present here today is a digital literacy project. We do an analysis about digital literacy in the US. And I did ask my friend LLM a question regarding digital literacy and quantifying digital literacy in the US. And because it doesn't have access to any data, it doesn't have a good answer. So even for these kind of systems, if we don't provide open data, if we don't provide information, they can make up answers, we know that. But they can really answer the questions. So even for this, it's important for us to think about these data gaps, right? So as I mentioned, we from Microsoft, but this is not something exclusive from Microsoft. Other tech industries are also working on this, have been thinking about this. I am going to talk about Microsoft because that's my team and that's who I've been working for, but it's not a Microsoft exclusive thing. But from a Microsoft perspective, it's super important. It's such a priority. And the one specific, we have an entire portal with open data sets, but the one specific data set that was built using Microsoft's data is the broadband usage data set. So this is the only data set currently available. I'm going to talk about this data set, and then another data set that is coming up this year as well. So I'm going to go through the process of creating and thinking about these two data sets today. So to start talking about the process, I'm going to bring a quick example of how the opening data process is defined in other organizations. So other organizations have been thinking about it as well. When you're going to start an open data project, you're going to create an open data set. There are so many things you need to think about, So you think about the problem, you think if there's a data gap, how relevant the problem is, and then you think about little details regarding the risks, regarding partnership, regarding data governance, and et cetera. Today, I'm going to break down all these different pillars and metrics into 4 different pillars that we have when we start thinking about an open data project inside Microsoft. So the first aspect we think about is always, we need to identify socially relevant issues. We're opening data, and it must be something that is going to be helpful for at least a couple of different sectors. Otherwise, we're opening ourselves to a risk here, so it needs to be worthwhile. And of course, not only an important issue, but an important issue where we're actually filling a data gap. Once we have those things in mind, then comes the interesting part, at least interesting for this audience. So the privacy design. Privacy design here is always thinking about the higher standard of privacy to Microsoft users. And then the final pillar is the process transparency. So from being very transparent about the data, the privacy preserving data pipeline, to the libraries we use, mechanisms, in the case of differential privacy, to data utility. We try to be very transparent about all these aspects. So not only the user understands well, not only the Microsoft user, but also the data user understands well how the process was done, and that is a trustworthy process. But we're actually interested in increasing this kind of data publication in society in general. So being able to contribute by providing transparency regarding what we did, we hope that this will influence other organizations, maybe smaller organizations that have less resources, and then as soon as they have access to this kind of documents, this kind of data sets, this can sparkle something, and other organizations can do the same, and we have more data out there. So as I mentioned, first step for us is to identify socially relevant issues to fill the data gap for socially relevant problems. So I'm going to talk about 2 data sets today. And the first one here, which is where it all started, is called the broadband data. So the broadband data is the first data set to publish broadband usage estimates. And this is US data only, so broadband usage across the US. And we did that at a zip code level. And how we did that was we used Microsoft telemetry systems. We actually used 2 different telemetry systems to understand the devices that were actually using and devices that were not using internet at broadband speeds. And then another telemetry system that we had to use to adjust for market share. So there was another telemetry system that we also had to query for that. So it was basically tapping into 2 telemetry systems and counting devices from those 2 telemetry systems. So it's not an overcomplicated process to build this specific data set. It was an amazing project to work on and to understand how to do this in a very responsible way. So we chose a simple project, simple to motivate, simple to communicate on purpose. It was very successful, and it was very successful because with this data set, we realized one thing. Broadband availability and broadband usage are two different things, and this data set provided that. So this is available on GitHub. You can take a look at any time. But we realized that we get data out there and we get these insights that are so important. These insights are important not only because they are interesting and cool, but these insights have been used by regulators. These insights have been used by the White House to understand the digital divide in the US. But also, these insights have been used by people that are thinking about the digital divide issue in the US and understand that infrastructure is not the only thing you need. So this is the broadband data set, and I'm going to go into the details about those pillars that I mentioned. But before I go into details about the broadband data set, I want to introduce you all to another project that we also worked. And this is a recent project. The data is not available yet, but it's coming up very soon. But I'm allowed to talk about it. And it's the digital literacy data. So inspired by the broadband data set, once we finalized the broadband data set, we understood that broadband usage was a very interesting metric, very important metric, and that data set was being used inside Microsoft by many different teams, outside of Microsoft by state regulators, federal regulators, but also researchers in academia. So we were understanding now a little bit better which percentage of the population was actually using internet at broadband speeds. But then we started asking ourselves another question. So, okay, so they are using internet, but how are they really using their devices? How are these people interacting with their digital devices? And we wanted, and that question was motivated because we felt like having access to the internet is not enough. You have to have some kind of digital literacy to use the internet well and use your devices well. So we were trying to answer this digital literacy question. And by looking at our data and looking at standards of digital literacy and how this has been defined by organizations such as IEEE and OECD, we realized that digital usage of devices was actually a very interesting proxy for digital literacy. So the whole idea with the digital literacy project is to create a data set that summarizes the usage of digital application across the US, again, by zip code level. This specific data set showed us another interesting thing, which was, again, infrastructure data is not enough to explain the digital divide. So when we plotted maps, and there's also an upcoming paper with an in-depth analysis. So this project was done by Microsoft in partnership with professors from the Harvard Business School and the Wharton School of Business, where our partners are really interested in understanding what are the impacts of such data set? What are we learning by looking at this kind of data? So what we learned is that when we look at the availability versus, so this is one of the indices that we made available. We see that, for example, this is the county where Chicago is located. So I didn't realize that. I forgot to point out that this is Chicago. So sorry for that. So this is Chicago. Chicago has an amazing infrastructure for broadband, for 5G. It's really, truly amazing. But when we take a look at how the population is using their devices, and we compare to education attainment and income, we see a story here. We see that we need more than just infrastructure. We need actually to understand how the different populations are using their devices, and then that will give us an idea of what needs to be done so we can actually, reduce the digital gap, the digital divide gap. So with those motivations in mind and those projects in mind, let me go back and talk about the privacy design and the process of making all this super interesting data a reality. So when we think about these projects, the first thing is, as I mentioned, we are interested, or it's a must for us, to have privacy guarantees that are strong enough and that will give our customers the understanding that we're not only doing, I'm gonna call it a good with their data, but doing something good with their data, but we're also providing them very low risk here when we do this kind of data analysis. So, and I understand that for the common user, this is when I say that we're using differential privacy, we're using such and such mechanism with certain privacy parameters. It's not super easy for the regular data, Microsoft user to understand that, but the whole idea here is that when we think about our choices, for example, for the broadband data set, we were very much thinking about the user in small zip codes. That was the user at the most risk, So for those users, we wanted actually to guarantee that we were providing a very, very strict privacy guarantee, because we knew that broadband usage correlates with socioeconomic markers, including income. So it's an amazing income predictor. And we, on purpose, were very strict. So many of you might be familiar with differential privacy and some of the parameters. But when we choose such mechanisms with a small epsilon, so an epsilon of 0.1 is considered a fairly small, reasonable epsilon for real-world applications. When we do that, we have this assurance that we're actually providing a very good privacy guarantee for our customers. So this was the thought process behind the privacy design of this data release. And then for the digital literacy data, what we're actually doing was not just, a binary marker, broadband, not broadband, like the previous example. For the digital literacy data, what we had, we're creating an index based on the usage of digital applications. So for each device, and this is all made up, don't worry, this is fake data. So for each device, we're actually looking into how many minutes each device was accessing different applications. And we built an index that was summarizing the usage, not only regarding intensity, but also regarding variety. And we summarized that into a single number. The way we summarize that is using a technique called PCA. It's a very common technique in economics for building economic indices, and we're using this technique here. But as you can see now, for each device, it's not a binary indicator. It is a number that is summarizing intensity and variety. So as we compute these aggregates per zip code, and by computing these aggregates per zip code, where all our aggregates, they do have differential privacy on top of it, what we realize is that these numbers, they actually, although we know that they will have strong correlations with income, strong correlations with education, it is kind of hard for you to point out exactly what that device was doing. It is a number that is summarizing whether you're using a lot, a good variety, but to point out what the device was doing is already hard just by looking at the raw data. Suppose we don't show anything, we just show those numbers. So when we thought of that, we understood that for this specific project, we could be a little bit more generous with our privacy budget. And we felt very confident that even being more generous with our privacy budget, thinking that this is the worst case scenario, this is our maximum risk that we're allowing ourselves to take, because of the nature of the data and what this data is capturing, it's really, really hard, if not almost impossible for someone by looking at this data set to make any inferences regarding what are they using in their devices, how long they have spent using the browser. It's not going to happen. So the thought process behind this other data set when we're doing the privacy design was different because the data itself was different. As you can see here, different projects will have different thought processes, and they will have different privacy budgets because the nature of the project, the nature of the data is different. Yes, so exactly what I said. So our takeaways from the perspective of the privacy design here is that we're always taking into consideration the scenarios, always taking into consideration what are the risks involved regarding those data sets and the risk of revealing something that might be important for our users regarding that data. And then moving on, I want to talk a little bit about the process transparency. And here is, as I mentioned, there are two different reasons why we do this, two different reasons why we believe this is super, super important. The first one is that transparency is always going to be our friend. Being transparent about the process will help us identify way faster where can we get better, right? We divide that with the community can give us feedback, and it's always great. In addition to that, the other reason is usability. When you know how the data set was constructed, it's much easier to use the data set. But it's not only about the construction of the data set here. The process transparency here is also, from our side, we do some error analysis, either via simulations or we do a differentially private error analysis, and we try to, and when I say error here is how far our DP data set is from the real data set. Because we want to publish something that, on one hand, is not providing any risks to anyone, but on the other hand, it should have information, right? So those two things are very important. And as I said, the first pillar, and this slide is not meant for anyone to read and understand, it's just an example of how we want to communicate things. So our first pillar for transparency is we want to communicate everything we do, all mechanisms, all libraries, if possible, with code examples of what was done, everything, every step, in a very transparent way. And then regarding data utility or error estimates, there are a few ways we can do that. For the broadband data set, we made several simulations. So that gave us the error estimates for free in a way that we took our differentially private data, so that was already privatized. And then on top of that data, we simulated, what would look like these error bounds. So all the error simulation process was a post-processing. It was a post-processing part of the pipeline, which was possible for this project. Sometimes, for some specific data utility analysis, these simulations are not going to give you exactly what you want, so you actually want to compare with the real data. In that case, you can do differentially private error estimates. But the whole idea is to find a way to try to communicate these errors in your data. So our published data, and this is our published data on GitHub. So we have CSV file. It's as simple as this. The whole idea is to make it simple to use, easy to access. And for each of these data sets, we have, county name, county ID, postal code, broadband usage, which is the percentage of households, the estimated percentage of households that are using internet at broadband speeds, and then all those errors right next to the broadband usage is an estimate. So it's the mean absolute error. We also have the error range, the 95th percentile, and we also have the mean sign error. Everything here is supposed to help the user understand whether that statistic that they're looking for to use, sometimes it's for something that actually requires the statistic to be fairly accurate, so that's why we provide those error ranges. And then again here, the takeaways. We are always thinking about having a very clearly defined data pipeline, being very transparent about that, and then try our best to clearly articulate the utility, either using simulations or differentially private error reports. So what is next for us? As we do these data analysis inside Microsoft, I feel like the most important thing for us right now is, one, open data, of course. We're opening these data sets. We had been very much focused on digital equity and the digital divide. We felt like that was a place where we could actually contribute a lot with our data. And we have been doing that for the past few years. Very happy with the results, very happy with how the external community have been using the data. But as next steps, we're really looking forward to have more people engaging with us in this. So not only us, Microsoft, opening up our own data, but have companies that, or organizations or NGOs or even research institutions that haven't been comfortable with this process, understanding that we as Microsoft have been doing this, we are okay with the risk in opening more and more data, hopefully, right? So that's it for today. Thank you so much. I appreciate so much this audience and being here. Thank you.
So we're just going to have a short fireside now with Paul and Mayana, apologies, and then we'll push the coffee break by probably 5 or 10 minutes. Okay? Thanks.
Thank you very much. Thank you for a very interesting talk, Mayana. Before we start, could we just have a show of hands? Who knows what differential privacy actually is? Okay, so that's probably less than 50%. Who actually uses it day to day in their jobs? So a bit less again. Okay, so that's interesting. Okay, so I'm not going to get too technical with the questions today, but we'll see how we get on. So first question for you, Mayana. So you talked about using telemetry data. Do you primarily use Windows operating system, or do you look at other devices, Microsoft products on other devices as well?
So that's a great question. We have, for those two projects, we have used mainly data from Windows telemetry systems. We have explored other telemetry systems as well. We do have browsers, we do have search engines for those Windows, but it will depend on the type of social problem we're tackling. For the digital divide area, Windows seems like the best one, but we would love to explore other options, yes.
Thank you. Now, you mentioned a little bit about the data collection process. What safeguards do you put in place to ensure that you can't access the raw data when before that DP is added to it?
So when the whole process, as a data scientist, we, at least from our team, we don't have access to raw data. We already have access to anonymized with certain aggregations in place. So when I access the data, although it's in a trusted curator scenario, it's not a trusted curator directly looking into the raw data. It's a trusted curator looking into a already sanitized version of the data. As you can imagine, there are certain tiers of how can you access this telemetry systems data? And for this specific project, we are interested in aggregations at zip code level. So it's a fairly simple, data that we need for that when it comes to telemetry data. Yeah.
Thank you. So you mentioned a few of the use cases for the broadband data, and I know that study was done a few years ago now. Have you seen any positive outcomes from the publication of that data?
Absolutely. I think so to give some context here, we receive probably a handful of emails every couple of weeks asking questions about the data, researchers, people from, state governments, federal government, asking us a few questions regarding the data, how to use or certain things so we know they're using. But it was very rewarding and surprising when we realized that the White House was building this US map explaining the digital divide, and they were building it using a few data sets that were publicly available, including ours data set. So their whole planning for budget and in the infrastructure of the US was done using our data set, which was very rewarding when we saw that. We finally understood that, wow, this is an area where you put data out there and it gets used, like really used, and the investments of the US or in this area is, decisions are being made based on this data set.
Thank you, Mayana. So you talked a bit about the privacy budget, Epsilon. I know for people familiar without a DP background might struggle with that, but in terms of the privacy budget, how did you come to that particular value? Was it an iterative process? Did you look to other industry releases as a guide? How did you come to that value?
Yes, so all of those things together combined with the fact that it's not a one person making the decision, right? So we have different teams, different people, different backgrounds. We have lawyers participating and thinking about it. We have engineers, we have privacy experts, so it's a combination of that. But it's very much a by use case process. I briefly mentioned here that for the broadband data release, especially our lawyers, partners here, they were really thinking about the risk of, hey, this data is actually giving you a binary indicator, broadband, not broadband, and we already know that broadband is an amazing predictor for income, so we need to be very strict here. That was the one thing that we were very sure, be very strict with the broadband. Other data releases, we understand that it's a different kind of information, it's a different kind of risk. So depending on the project, it's a different thought process, but it's always a thought process that takes into consideration other data releases done, similar data releases done in the industry, and what the data is about, right?
Thank you. So in terms of the underlying libraries that you used, which ones did you choose for the project and why did you make those decisions?
Yes. All of our projects, inside our AI for Good team, we use OpenDP. So OpenDP is our biggest partner. Not only because when it comes to transparency and trust, we feel that OpenDP will give us all of that, but having a partner like OpenDP, as soon as we think about new mechanisms or new functions, OpenDP has always been this great partner where we can talk about, what are these needs from if you're opening data for social good, this is something that will be useful not only for us, but we can see other people using that. So we partner a lot. So AI for Good has always used OpenDP, and it has always, we've always been a big fan and cheerleader for OpenDP, yes.
Thank you. With the broadband study, for example, do you anticipate you'll be updating the data over time to reflect changes in usage?
Yes. I think the whole idea from the beginning was to have a new release every 5 years. So 2025 would be our expiration date for a new release. Hopefully next year we'll have new broadband estimates. So now we can have a comparison from 2020 to 2025 and understand how this has evolved.
Thank you. In terms of explainability, I know you spoke a bit about transparency, but maybe for some people not familiar with DP, looking at all those equations will probably, be difficult.
Yes.
How do you approach explainability from a non-expert level, conveying what's going on behind the scenes?
The usual approach we take is try to quantify the risk, meaning suppose you have a scenario where you have access to this database. And then we actually quantify by communicating to our audience, by telling a story based on, suppose you have access to a database with these characteristics. If you use this mechanism with this settings, this is, and then we quantify, in a probability, this is the probability in the worst case that you could actually infer if someone is in this data set or not. So we try to come up with these, and then if, depending on the audience, even the concept of probability, we need to dig a little deeper in terms of let's break it down. We always try to start by let's try to explain this to a non-technical colleague, and then but sometimes our non-technical colleagues, they have a lot of context, right? So, and then we break down into, let's try to explain this to your friend that I don't know, your neighbor that is absolutely out of the industry and so on. So we try to think about what terminologies would be important here, but that's the thought process. And then there's also the way to communicate to stakeholders and leadership, which is a different way. So it again depends on who you're talking to, but it's always trying to give them an idea of what are we exposing here and giving some insights in terms of numbers.
Thank you, Mayana. Okay, could you tell us a little bit about some of the upcoming work that you've talked about, obviously the broadband work and the digital literacy work. What do you see your team doing going forward over the next year or so?
Yes, awesome question. Thank you for that. So we've been very much focused on the digital divide related issues, digital equity, and how can we, as Microsoft, be helpful in terms of, doing something about the digital gap and this digital equity gap in the US. Next step for us is to maybe shift a little bit problems and think more about problems related to sustainability, problems about climate change, and inform populations about the effects of climate change. So that's where, and you asked about Windows telemetry data, that's where that is when our minds started shifting from Windows data to maybe something like, browser data or research engine data for those type of problems. This is where I am, currently trying to go to. Hopefully we'll have interesting things on that side coming soon.
Thanks, Mayana. I guess on that point, what about the potential to collaborate with other large players in the field? The likes of Apple and Google and so on, using differential privacy as well. Do you think by teaming your efforts together, do you think it's possible to have greater impact?
Oh, absolutely. So when we did the digital equity works, including broadband and digital literacy, one thing that we noticed is that Windows data was actually great for these type of works, because when it comes to laptop and desktops in the US, we have the majority of the market share. This is public information, everyone knows it. Even the LLMs know it. But the thing is, when it comes to other problems, we might not be the majority of the market. So we would have visibility into fraction of the population, but we wouldn't have the advantage of seeing a good part of the population, right? So that's, for those specific problems, that's where partnering is such a good solution, because now we can, each one of us would be seeing a different partition of this population, right? And then by collaborating, we would collectively see a better picture, which is important if you're actually trying to inform people by opening data. If you see just a part of the population that isn't giving you some, probably a biased information, right? So it's nice to have, more than just a small piece of data.
Mm-hmm. And on that topic, you mentioned that your data collection is limited to the US. You talk about things like climate change, that might require, collection from a wider area. Is that something you're considering, or is that, some?
Oh, absolutely, yes, absolutely. I think that with differential privacy, we feel very comfortable that that would actually meet the standards for many jurisdictions for privacy, preserving data analysis and opening data sets. So for climate change, for example, to do something more like a worldwide view of a specific problem, that would be absolutely something we would consider.
Thank you. We're nearly out of time, so last question is more of a general question. How do you see the landscape changing over the next 3 or 4 years or so?
I would love to see organizations that have data but are not really doing it start doing it more and more. When I say it, is open data that could be potentially, violating someone's privacy, user privacy, if not done in the right way. But with these examples, as people see this more and more, they feel comfortable in doing it with their own data. So there are so many NGOs with interesting data, they collect data, and so many different and impactful problems. And we would love to see more data out there. There are problems, important problems, and I'm giving sustainability and climate change here as examples, but you have important problems that related to, gender, related to children's safety, and we don't have data out there, So it will be very interesting to see more open data, more information for those areas as well.
Thank you very much, Mayana. I think we're out of time, so big round of applause for Mayana.
Thank you.